Okay, I'll get started in the interest of time. First of all, good afternoon. It's an absolute honor and privilege to be here. Of course, never visited PSD Tech Campus before. Been to PSD Arts and Science maybe some years back, but I have to say that it's such a nice place to be here and great to see all of you. See, we have all had a good lunch, so it's not easy to do a session after lunch for you as well as for me, but I'll try to keep it as much as interactive as possible, right? So my name is Karthik Vaidhyanathan. I'm an assistant professor at the Software Engineering Research Center from IIIT Hyderabad. I just saw a gentleman asking a very good question about, power, right? So we're only going to talk about that, right? Sustainability of AI-enabled systems, because we talk about AI a lot, but what about the power concerns, right? So that's what I'm going to address, and I head the Software Architecture for Sustainability Research Group within SERC. So I don't know how many of you know Donald Knuth. Please say many, hopefully. So he's a Turing Award winner, right, in computer science, right? If you have learned algorithms, the art of computer programming, there is a great book, series of books by Donald Knuth, right? In fact, he says something very interesting about yeah, it's okay, leave it. About, what he would like to see is like thousands of computer scientists, right, let loose themselves out, and that's what really advances the field. Now, why I said this as a caveat in the beginning of my presentation is some of this could be far-fetching, right? And I hope that as computer scientists, that's our responsibility, and we believe that the industry will also catch up at some point, yeah. So a little bit about myself. As I said, I work in the Software Engineering Research Center. So I happened to do a master's in machine learning at some point. That time AI was not so frenzy as it is today. And then suddenly I ventured into software engineering. Don't ask me why. I was outside, so I thought I'll do like double master degrees. So it was one master's in machine learning, one in software engineering. Then I was like, what will I do next? I played around with industry for some time. And then I realized that academia is my calling, and I went back. I did a PhD, and that was at the intersection of software engineering and machine learning, right? So whatever I do it like, how can you engineer AI systems on one side, and on the other side, how do you use AI to improve your software engineering practices, right? So that's the dual objectives that we focus as ML for SA and SA for ML, which is more from a software architecture perspective. Some fun facts: I'm a big cricket fanatic and a movie buff. I ensure that I watch as much as movies possible, right, whenever I have free time. And of course, a big cricket fanatic. Yesterday, you know what happened? Australia won the Ashes. Happy about that. And I'm from God's own country, Kerala, just 1.5 hours away from here from Palakkad. Yeah. So just like water everywhere, it's AI everywhere, right? Every day somebody is talking about AI, right? Suddenly, we were having this discussion over lunch with Mukund. I think he left, right? So we were mentioning about last 4 years, suddenly it's all about AI. Till then, many people didn't even realize what is the capability of AI. It's becoming a very horizontal, right? Every day someone is releasing, somebody is talking about, am I going to lose my job? Somebody is talking about deploying AI on your phones. People are talking about AI writing automatically code, right? A lot of interesting things are happening, right? It's all good. To the extent, when I went to, that's a very nice, thing that I've put. When I went to this conference in Spain, in Portugal, I guess, I had a car, and that car had an LLM in its number plate itself, right? So that's the level of AI penetration that we are talking about. Not that it was actually LLM, but it was just, pun intended. Anyway, so if you look at what is happening on the other side, right? Although AI is going, we can see there is a digital dark matter here. And what is that dark matter? Right? The dark matter is about the energy concerns, especially the electricity, the carbon emissions, and the water, right? These are less talked about. I'm happy that some of us are having this discussion today. I'm super happy about it. In fact, I was typing to my research group, hey, I found people who are actually interested in sustainability, right? At least we are talking about it, right? And why it is important. See, this is the recent article that came from Verge. It was like few days back it came. It says that AI's water and electricity use source in 2025, right? And it says that AI created as much as carbon pollution as the entire New York City, right? Or the data centers consumed water, that is the amount of water that you consume in water bottles. That's like almost billions of liters of water, right? That's the amount we are talking about. And on the other side, we have stats that come says that data centers are expected to consume 3% of world's electricity by 2030. But if we are really talking about all this AI adoption going, I'm sure that that number will skyrocket, right? So the question then is, what are we doing about it, right? So it all comes down to this point, right? Software needs to be sustainable. And the moment you talk about software sustainability, the standard definition from ISO goes like this, right? Is defined as the capacity to endure, to preserve the system over a period of time, right? So you build a software, you want to ensure that the software does not degrade, it performs as it is expected. I mean, it doesn't work like that, but that's the expectation, right? But is it only about that? What about this? So Green Software Foundation in 2023, right, which is this consortium of people and it's under Linux Foundation, IIT Hyderabad is also a member, is they came up with this report which says that software emissions, I'm not talking about AI, I'm just talking software because ultimately AI is also a software, right? Emissions are equivalent to air, rail and shipping combined. Are we even mindful of this? We all talk about using softwares for ESGs, right? But we never talk about the ESG of software itself. What about that? Right? That's why we say it's a digital dark matter, right? And that also needs to be accounted for, right? So let's get some basics right, because you might be wondering, I mean, what is this guy talking about? Sustainability, software, carbon emissions, right? Let's go back to 8th grade, 9th grade science, right? We all know that, I mean, we emit a lot of gases, right? I mean, in terms of pollution, I mean, manufacturing that is happening, industrial manufacturing that is happening, emissions that are happening, a lot of gases are getting emitted, right? Could be CO2, CH4, CO2, N2O, and so on, right? In that, one of the most key element is the carbon, right? Of course, carbon is the one, and it's important. These are getting emitted because they trap the heat, and that's why Earth is maintaining a temperature. Otherwise, we'll be going in -40, -50, right? So it's important that these gases are emitted. The problem is when these gases are emitted more than what is needed, that results in global warming, right? That's what we have been talking about. Now, how does this emission happen? This emission happens whenever we burn some kind of a energy source, right? It could be coal, it could be fossil fuel, right? It could be oil. Depending on what energy source you are using, you are going to get energy, but at the cost of emitting some carbon, right? And this carbon, of course, has an impact on the environment, right? I hope this is clear, right? So you emit, you burn, you emit, and that has an impact, okay? That's it. Let's keep it simple, yeah? So now the question is, can softwares consume energy? Well, the answer is yes, in many ways, right? One is, if you have to run a software, you need some kind of a hardware, right? So this hardware it won't appear magically, someone has to manufacture it. So when you manufacture this hardware, you are going to consume some kind of power, right? To get the material for the hardware, you are going to get some kind of power, right? So these are typically called embodied carbon. You don't see it outside, right? Because whenever you buy a machine, this MacBook that I have has been built by emitting some carbon. Great. Now I'm going to run a software on this, right? And when I run a software on a hardware, this hardware is going to consume some power. Now that power is because of some carbon emissions, right? Now think of a data center. This is one computer, but think of like hundreds of computers. These machines get heated up, right? So I have to cool them. In order to cool them, I have to supply some water, right? So it means what we are essentially talking about is, for just doing a simple hello world, right? You are having so much of implication on carbon footprint. Now, depending on how intense the program is, this carbon footprint will go up, right? So that's why we say softwares can consume energy, right? Now let's do some math here. Now, typically this is quantified by something called emission factor, right? So depending on which country, which region you are in, right? Say India predominantly uses coal and fossil fuels, right? We don't have a lot of, renewable energy that we are using, unlike Europe, which is, let's say now it's becoming more solar, wind, and so on, right? So what happens is, depending on, what is the amount of carbon that is being emitted and the electricity is generated, you get an emission factor. That is for a particular region. So how much energy was generated in India? For generating that, how much carbon did I consume? This will give me an emission factor value. So there is an emission factor value that is recognized by the international body for this. So depending on how much electricity you consume, you just multiply with the emission factor, you will get a ballpark scenario of what is your carbon emissions. That's how you calculate carbon footprint. If somebody will tell you, oh, I consume this much amount of carbon, what does that actually mean? That means they got the electricity that they consume, they multiplied by emission factor, they got the value. This is a simple math. Now let's go a little more further down, right? So assume that you have a cloud service, or for simplistic thing, you are just training a machine learning model, right? And it consumes 200 kilovolt of energy. How did you measure? You have tools to do that. If you're using Intel, you have something like PyRapple. If you're using NVIDIA, you have something called NVML. So there are a lot of tools to do that, right? So now imagine the region in which you are running this training, right? Let's say in India, in Coimbatore, you have a server and you're running it here, has an emission factor of 0.5 kg carbon dioxide that is being emitted, right? Essentially, your total emission is 200 into 0.5, which is 100 kg CO2, right? And that is almost equivalent to 400-kilometer drive in a petrol car or charging 12,000 phones. Now you understand the implication of it. Now if somebody tells you, hey, I trained ChatGPT, I created a model and it got trained for, tens of days on thousands of GPUs with this much of power, you can imagine how much power did we consume. I hope now the number doesn't look scary, rather it makes more sense. So what we're essentially talking, thanks to Mukund also, he introduced this word briefly in the morning, which is uncertainty, right? AI systems comes with a lot of uncertainties, right? Because as I said, we are incurring this carbon footprint that is primarily because you have to retrain your model periodically, right? People are going to use your model. Say you go to ChatGPT, you'll send a prompt. Every prompt will incur some cost. To the extent Sam Altman came out and said, please don't say thank you to ChatGPT. He actually said this because every thank you is costing them, right? It's hitting their servers. So he said, please don't do this, right? That's a harm, yeah? So what is happening is your system faces a lot of uncertainty because of which you have to retrain your model, you have to keep adjusting the parameters and so on. To the extent there are stats that says inference of machine learning, which is not training, right? When you send a prompt, you get a response. That's the inference phase. You're just using the model, right? It can take up to 90% of model's life cycle energy cost in terms of carbon emissions and so on, right? On the other side, Gartner came with a very interesting stat. They say that, I've kind of undertoned it for this audience, right? They say that more than 80% of the ML systems don't even make it into production. They are nice POCs, prototypes. Recently, MIT published a study that 95% of these agentic systems are not even there, right? They're all nice POCs, right? And you can talk to me later, I can give you examples from my own experiences, yeah? So there are a lot of uncertainties that comes in. So the question is, how do you handle that? And now, can you address over this? And what about the sustainability concerns? Now, you might be thinking this is a new topic. No. In 2014, there was this Karlskrona manifesto that came from ICSI, which is the International Conference in Software Engineering. They came up with this manifesto that said, if you're talking about software sustainability, you have to look from 5 dimensions. It's not just environment, because I can go to a company and say, oh, you know what, you're incurring so much of carbon footprint, shut down all your servers. Man, what about business? Right? So I cannot do that. So I have to be mindful about my economic impact, about the energy impact, about the technology impact, what about the people who are involved in building the software, and how good it is for the society. So if you look at Zomato, Swiggy today, right? I'm not endorsing any of them, by the way. I'm just saying, if you look at any of these food delivery apps, they are now asking, do you really want a spoon or not? Do you want cutleries or not? Why? Because they also want to be mindful, right? So it has to be good for the society when you build a software, right? So it has multiple dimensions. Let's put it this way, yeah? To the extent in 2019, it seems there was a study that came, Netflix consumed power that, amount of energy that could power 40,000 households in the US. So can I come here and say, don't stream in Netflix because you are consuming energy? No, that doesn't make sense. But how can we build softwares that are more mindful of energy, right? So what we did is we also started thinking about this, especially from the AI side of things, right? Because we know that inference consumes more amount of energy, we were looking at what can we do from this, right? We have been doing a lot of work in the last 8 years in this field of software sustainability, right? I'm not going there. What we observed is for the same task, you can use multiple machine learning models. Most of the times. So the moment somebody says computer vision, your question is, are you using YOLO, Detectron? There are so many models that are available, right? And each model has a trade-off. Some models consume more power, some models take a lot of cost, but they offer higher accuracy. Some models will offer less accuracy, but higher cost. So there is always this trade-off that you have to look at. The same goes with language models as well. If you look at the LLM domain, right? You have proprietary models coming from Anthropic, Gemini, or the OpenAI, and then you have a bunch of open source models, you have a bunch of agentic systems, right? By the way, if you're wondering what is that, it is LM Arena, right? You can go there and pick which model you want based on the performance, or you could go to SweBench and pick models that are good in software engineering task. So what I'm essentially trying to say is for the same task of language model, right? Just generating text, I have this hundreds of options that are available. Some models are good in certain kind of task, right? So the question then we started asking is, can we use something like a self-adaptation, where can we teach the softwares to autonomously adapt themselves in such a way that they are mindful of this cost, energy trade-off or performance trade-off. Now, what is self-adaptation? So this concept came in, this goes into the direction of autonomous system. I'm sure there is a nice keynote coming after this, right? So there is this 2003 paper from IBM, from Kefart and Chess, that talks about this idea of vision of autonomic computing, where they said, what if systems could adapt like human cells? Right? Where the idea is, let's say if you get a small injury, right, you won't probably even apply anything. It'll automatically heal by itself. So can systems also autonomously heal by themselves? So this is a question that was asked. So based on this, there is a conceptual model. So if you have a running software system, you constantly monitor the software system, you see what is happening in the software system, and you keep updating that software system, right? You could use AI, you don't have to use AI. There are so many ways to do this, right? So our question was, can we now adapt during inference? When somebody is asking a prompt, by the way, this switching between models, right, that Perplexity is doing or now GPT is doing was not there 3 years back. So our idea at that point, I'm saying this as a caveat now, and now I'll explain what the idea is, right? So our idea was, based on the context in which you are using the input, can I decide what model to use in such a way that I optimize for energy consumption without, trading off a lot on the accuracy? So this was the questions we started working with, right? So we came up with this idea of something called machine learning model balancer. Depending on the query, we'll balance between different machine learning models. So this resulted in a bunch of nice, in academia conference publications, A-star conferences, right, in software engineering. So it was good, right? Interestingly, when we presented this in ASC, which is Automated Software Engineering, one of the best conferences in software engineering, one guy from Google came and asked, this looks scary because you guys are switching between machine learning models. What about the reliability? And guess what we are doing in 2025? Gemini is automatically figuring what model to use based on the query you are asking. So it's not that it's not possible. It's possible because it makes a lot of sense, right? So we created this tool also where people could use, they could go to this website, they could take this tool, and they could come up with different switching strategies. We came up with a very simple epsilon greedy. I'm not going into the technical details of it. And we said you can actually switch between different machine learning models at runtime. And we implemented this for computer vision. So of course it was a huge, instant success. But that time we were not looking at energy as a primary criteria. It was between performance and accuracy of the model, right? Performance of the system, which is latency, how quickly you're able to give the response, yeah? And then we said, why don't we take this to energy also, right? Where, there is a bunch of, machine learning models. So you have different YOLO models that are available, like nano model, small model, large model, extra large models. So there are different types of models, spectrum of models that are available. So our question was, can we dynamically decide which model to use? And based on that, give back the inference, right? And we observed that we were able to do 50 to 60% of energy savings without trading off a lot on accuracy, maybe a 1% drop or 2% drop, and that is okay, right, most of the times, right? So this resulted in a very interesting work, and we said, can we go further, more low level, right? So at that point, Qualcomm was working with, they were having this Qualcomm Edge AI labs at IIIT Hyderabad. So they were having this SoC, this system on chip that powers your phones, right? So they had this chip that powers Samsung Galaxy S24. We are using this Snapdragon SoC, and they said and gave it to us and say, you can do whatever experiments you want. So I said, why don't we try this in a low-level mobile device where I want to optimize the battery performance of the phone by, creating such kind of a switching strategy. So based on the query you ask, it dynamically switches between different machine learning models. So we implemented this in, an edge device of Qualcomm, which is basically this interface. The same thing will work in Samsung Galaxy S24 as well, right? And we had this nice work published on, Edge ML Balancer, which is switching in the edge, right? Where you're optimizing between performance, battery life, and energy consumption, right? And trade-off, right? So this was cool. So we said, and of course, by the way, one more thing is you can find the video of the switching concept in Qualcomm's website itself, right? So they invited us for a Qualcomm's, education webinar, and we were one of the 10 selected universities, and we presented it, and it went into the website of Qualcomm itself as an idea of model switching. So what we did, we said, if we can do this to one aspect of machine learning lifecycle, which is just inference, what if we can take it to the entire lifecycle of a machine learning, right? And traditionally, if you look at it, one of the ways by which this is done, we say DevOps, MLOps, Agent Ops, AI Ops, so many ops are there, but we are just using the word MLOps here, right? So the idea is, if you look at an entire machine learning pipeline, you have this process of retraining your model whenever you feel that the model is, deviating from its expected output, right? Or the data distribution that is coming into the model might be deviating. There are many ways by which you judge this, and you might retrain your model. There are stories which says that some companies train models every 10 minutes, Every 10 minutes, there is a continuous retraining that happens. So we were asking this question, are we mindlessly retraining or are we carefully retraining? When I say mindlessly, if I suddenly decide to retrain, should I retrain now or should I retrain later when the load is high on, low on my system? Should I retrain in India or should I retrain in Europe? I'm just giving an example of Europe. In some other country where the carbon footprint is low, right? So can I decide this in such a way that I do it more mindfully? So I can switch between models. I can probably use an older version of a model. I don't even have to do retraining. So I have more strategies that are there in front of me. So how do I optimize my, carbon footprint, right? And of course, again, academia, this got published, but that's not the point. The point is this, right? Our idea, when we applied it on a traffic scenario where, the number of vehicles were there and we were predicting the expected traffic. This is based on a collaboration with a UK university as well on an intelligent transport system, use case. We observed that when we are using our approach, which is called Harman E, which is on the rightmost side, we observed that we were able to save, let's say, 50% energy, right, with the similar amount of accuracy that best models like LSTM with periodic retraining was offering, right? And this periodic retraining we inferred from the literature. And when I say sustainability, I'm talking about sometimes your energy might go up, sometimes it might go down, but eventually you want to ensure there is a steady state, right? That's the goal we are talking about. So now your question might be, okay, Karthik, this is all cool, but what about generative AI, right? So in general, in generative AI, we have been doing a lot of work. We have been working across the software development lifecycle, right? We have started our works from requirements to design, something that we didn't touch much, explicitly, because I don't work much on testing, is software testing, right? But we have worked on all the other aspects of SDLC, and we have been doing a lot of work. If you are interested, you could go and check the website itself. The key takeaway is we observed that in most of these cases, small language models were very good. You don't always need large language models, right? LLMs are great, but you need them always, right? So that resulted in our, first work. That is going to be, just got published, but it's coming in April, right? ICSE is the A-star conference in software engineering for people who don't know. So what we did is we said everybody are trying LLMs and they are generating code, but are these code really energy efficient? Because tomorrow you're going to generate a lot of code with LLMs. Are they really efficient? See, ultimately these LLMs are trained on human written code. Do you expect human written code to be energy efficient? No, yes? Not always, right? So what has happened is somehow it has learned nice patterns that we observed that currently, we were looking at popular models, right? Like the DeepSeek Coder, ChatGPT, Code Millionaire, Speechless Code Llama, all those models. We observed that if you have human experts who are good in writing optimal code, right? That is still much efficient than the LLM generated code by large margins, right? In fact, we did a call out saying that industry or practitioners should be mindful of this, right? Because you are just taking code and putting at it. And it also goes back to what Mukund was mentioning in the morning, where you can take that 80% that is given, but you still need to work on top of it, right? So we hope it's always taken with a grain of salt. Yeah. So then the question, interestingly, was if we can do this, what about agentic systems, right? Where every agent is ideally using an LLM. Do you really need an LLM? So we did this work on can SLMs help? So instead of LLM, you take away all the LLM out, you create specific fine-tuned model, right? Small language models, which are very focused on a domain. So if it's code generation, I have a model that can only generate code. It cannot answer questions like, how are you, right? Now I take this model, very small model that can even be deployed on your watch if needed, right? Like 5.3, 5.4 are very small models, right? So we took those models, even we had 5.3 here, right? So we took those models and we said, if they can do this something called function calling, which is given a prompt, they have to call the right tool. That's what, it's a core of agentic AI itself, right? And we observed they are almost getting there. And guess what? We published this paper and then NVIDIA comes out with a very interesting paper saying small language models are the future of agentic AI. And we were very happy to see this, right? Of course, we don't get that limelight. We're a small lab, but we are happy that industry is agreeing to it, right? That was the most interesting thing, yeah? So then we went recently further up. We said, okay, now small language models can work. Code generated by LLMs are not always energy efficient, but what about the so-called, SW bench? See, SW bench is one of the most popular, benchmarks that are available where you can have agentic systems that can automatically fix code. To the extent that today anybody releases a language model, they will first say their performance in SW bench is this much better or this much lower, right? So what we did is we took some SW bench frameworks, there were like 4 frameworks. with two different SLMs like Gemma 3 and Quen, 1.3 billion model. And we said if they're really energy efficient or not, right? Turns out that it is not just about the SLM itself. So what we were just contradicting ourselves, saying that just by using SLMs itself, you won't solve anything. You also have to have an efficient architecture around it, because otherwise this reasoning or loop that happens in agentic system, that can consume a lot of power. And we observed some frameworks like the autocode rover, which is very good in solving your code generation problems. They consume a lot of power, right? Because of the back and forth loops that they have. So the main thing that we are saying is framework architecture plays a big role, and there is a lot of work that needs to be done there as well, right? So what I'm essentially trying to say is everyone plays a role, right? You cannot be like, what is my role in this? Yes, you have a role to play. If you are a developer, you have to write efficient code. And efficient code is not just about energy efficiency. It's been there in software engineering forever. It's not that we are suddenly inventing this, right? In fact, if you are interested, yesterday or day before yesterday, Jeff Dean from Google published a very interesting piece of, I would say it's one of the best pieces of articles written on how do you do performance optimization in C++. Please do give a read. Yeah. So everybody who is there as a stakeholder in a system's lifecycle has a very big role to play. May it be a database engineer, may it be a software architect, may it be a software engineer, software developer, everybody, because they can all contribute to it. Only then you can look at sustainability. You cannot look sustainability saying, I will become sustainable. Okay, fine, but what about others, right? Because you are looking at a holistic way. You cannot look at it, one side of it, right? So we have been also doing some works also from the industry relevant side of it. So one thing that I just want to highlight is very good work that recently got out even in the academic side, but it's also getting integrated into production, is with Lloyd's Technology Center in Hyderabad, where we are able to estimate carbon footprint just by looking at Terraform configurations, right? If you just give us Terraform configuration, we can say this is expected to consume this much carbon footprint, so please try to optimize for carbon footprint, right? So that's the level of thing, and then of course it got published and whatnot. Now it's being integrated into the production ecosystem itself, yeah. So, and one more thing to highlight is, since we were doing all this work, we thought, we wanted to also see, we could write a proposal to, our Prime Minister Early Career Grant, and we are very happy that this project got funded, right? So this project is called Sustained Project, where we are trying to come up with a software-centric framework for sustainable AI systems, right? And it is funded by the ANRF, Anushandhan National Research Foundation. We have started this project, and some of the works that you saw about Harmony, SW Energy are all part of the project itself, right? So this is funded by the Prime Minister Grant, and here we are trying to build frameworks that will allow different set of stakeholders, maybe architect, policymakers, developers, on how they are looking at sustainability itself, right? So what are the key takeaways? If you have not been listening any of this, suddenly you got up thinking, what is this guy trying to say here? I just have few points. And if you're really interested in research, please do take note of this, because there are a lot of problems that needs to be solved. To the extent that paper that you see there is some of us, 25, 26 of us, meeting at EPFL in Switzerland in January, where we sat together and we brainstormed and we discussed and put down a research agenda on what needs to be done in the community for looking at greening AI systems using software engineering, right? That's the title of the paper itself. So please do give a read. What I just want to say is that software plays a big role in climate change, right? And that's why I started by saying that it is like a dark matter that you don't see, but it has a huge impact, right? And we ignore it, right? It's not just about using EVs, it's also about writing efficient code, yeah? So sustainability cannot be an afterthought, right? You cannot say that I'll think about sustainability later, for now I want to release my system. If you go with that mindset, you will never be sustainable, because you have to start from the design itself, right? There is a lot of lack of awareness that's there. Right? Many students, many people have no idea about that software can be sustainable. I got introduced to it by a Professor Patricia during my PhD days, right? So it's important we create awareness. I'm hoping that all of you in this room, if you didn't take anything from this, at least take this message that you can play a role in climate change, right? And practitioners definitely need tools, because if I go to an industry and say, hey, why don't you do this? They'll be like, give us tools, give us plugins. We are developing that could be used in Visual Studio Code and so on, right? So AI offers a lot of possibilities, but responsible use is the key. And responsibility is not just about ethics and bias. It is really also the impact on sustainability and carbon footprint, right? So I'm happy that that's a theme of this, event itself, right? And again, domain-specific SLMs, which are are going to be the key going forward. It's not going to be everything LLM. It's about what you really need. And this also goes into the direction of privacy, better security, and so on. And sustainable agentic AI is a need of the hour. If everybody starts adopting agentic AI, I'm really afraid that we don't have enough power in the world to power those many solutions. So we really need to, we don't have to kill a bee with a sledgehammer, right? Try to understand what is needed for what use case. Just because AI is available doesn't mean you put AI to everything. Sometimes you don't need AI. All you need is a traditional programming, right? So please think about it. And when I say all this, I have to really thank my team, right? Because whatever I'm showing here is because I'm being a poster boy of this works, but credits to them. Mistakes are mine, right? They did all this hard work, and a lot of work has been done by all these kids, PhD students, master students, undergraduate researchers. Thank you so much, means a lot, right? So please feel free to check out our website. But the big question that I want you to think about when you go away from this talk is, the softwares that you wrote, are they really sustainable? I think you have to really think about it. Thank you so much for having me over here, and it was an honor doing this. And I hope that I did justice to at least giving you this idea of what is sustainability. Thank you so much.